Tangent and cotangent for the inverse trigonometric functions are slightly different, but they still have the same premise. So again, we'll deal with tangent first, and our notation is the following. The inverse tangent is denoted with this symbol and is not equal to 1 over tangent x, which would be cotangent x. Instead, the inverse tangent of x is also denoted as the arctangent of x. You'll see this pop up a lot in your study of calculus. So here's the deal though. We have the same situation where if I asked you something like this, what is the arctangent of 1? The input is a real number. The output for us is an angle. So we want to know what angle gets kicked out, or better yet, the better way of phrasing this is, what angle has a tangent value of 1. So again, if we take a look at the unit circle, we have a situation where both here and here for our two angles, this is just between 0 and 360 degrees. We've already got two outputs, pi over 4 and 5 pi over 4. Let me do that in the same color. Both of these angles have a tangent value of 1. So which one do we pick? Well, we need to restrict ourselves. And so we are going to restrict ourselves the same way that we did sine. We're going to restrict ourselves on this interval between negative pi over 2 and pi over 2. So the answer for this is pi over 4, because pi over 4 falls on the interval from negative pi over 2 to pi over 2. Now the difference with tangent and let's say sine for the inverse versions of their functions is the following. If I ask something like this, what is the arc sine, or what is the inverse sine of 3, this has no solution. And the reason for that is because there is no such angle whose sine value is 3. There's no way to get a height on the unit circle of 3. So this is impossible. However, if I ask this I can find an angle for. This guy is not a problem because the tangent values I can get as steep of a slope as I want here. Remember, the tangent, there's a couple ways of thinking about tangent, but tangent could be the slope of this line coming out. And so I clearly can get any slope I want between negative infinity and positive infinity. So the input, or the domain, for the arctangent, that's all real numbers. I can plug in anything I want here, no problem. However, for sine and cosine, I can only plug in, so we're talking about the domain here, of the inverse sine and cosine functions, I can only plug in values from negative 1 to 1, because that's all that makes sense. Now, how do we figure this exact value out? Well, if we have this on the unit circle, we can go with it, but we don't, so we'd have to use a calculator for this portion of it. So let's go ahead and see if this works here. So I'm going to work, just so that you can see this, I'm going to work in degrees because it'll be easier for you. I'll have to restart this. And we can do it in radians, of course, but the degrees is just nice because it'll make sense. So if I do arctangent of 3, it tells me that at 71.57 degrees roughly, the slope of that line is 3. But if I type in what is the arcsine of 3, it's going to tell me there's an error because I plugged in a number that didn't make any sense. So now what about cotangent? Well, cotangent also has an inverse trig function, and so it's not used nearly as much, but it's denoted by cotangent -1, or inverse cotangent, or arc cotangent, like this. Now, because arc cotangent, if we try to use the same interval on which to define it, let's go ahead and try that and see what happens. From -pi/2 to pi/2, if I asked something like this, what is the arc cotangent of, let's say, 3? Let's see what that gives. We would get out some value, okay, and we could compute this. But the thing that we should notice is if we plug it in, we're not going to have an issue here. However, because of the way the graphs look, okay, and dealing with the asymptotes, we decide to define arc cotangent over the interval from 0 to pi. So this guy, its outputs will be on this interval. The inputs, again, the domain is from -infinity to infinity. Now this is just a convention for the way that we're defining the tangent, and well, the arc tangent and the arc cotangent. Okay, so it really more has to do with the way that the graph looks. Okay, but these are going to be the way that it's defined. So outputs for arc cotangent are going to be equal to this. Okay. So now let's go ahead and talk in the next video. Let's talk about secant and cosecant.